Hello, my name is Arham and I'm a junior in Tuscarora High School. And today I'm presenting my website for water retention suitability. All over the world, people are using water retention techniques to combat desertification. It allows water to stay in the ecosystem for a longer period of time, which helps replenish the environment and the ecosystems. Moreover, the recent floods all over the world has been devastating for communities. So this is our app. We are using Google Earth Engine apps for this app. It's pretty flexible. We can move it around. We can zoom in, and likewise we can zoom out. We'll click this compute suitability button later, and after clicking the polygon button, we will create a polygon of our map and whatever shape we want, and then we'll click this button to compute our suitability. I'm using this function to identify the state in which the polygon is made. The dataset I'm using for the land cover, which is known as NLCD, National Land Cover Dataset, which help us identify areas such as urban area, forest area, agriculture area, cropland, so identify which has better water retention in a landscape. Dataset I'm using for my elevation, which is known as DEM, Digital Elevation Model, which help calculate the slope of the terrain. So this is the dataset I'm using for hydrology, which is known as METAD dataset. It actually helps us identify the flow accumulation point in a landscape. So this is the dataset I'm using for precipitation, which is known as CHIRP, and I'm calculating the average rainfall the area receive. Here I'm using NHD, Natural Hydrology Dataset, to identify the water bodies and mask them so our points are not on the water. So this is the norm system I'm using to rank the suitability. So my slope is 0.30%, my flow accumulation or low norm is 0.35, the land cover score is 0.20, and the rain norm is 0.15. So first of all, we'll create a polygon, and we'll create a new layer, and we'll create a polygon on our map. After creating a polygon, we'll click this compute suitability button. It will detect the state, which is Virginia, and it will start computing the most optimal points for water retention, and it will display them on the map. They're loading, yeah. So these are all the points, and then it will also show their coordinates and their suitability. It will also show the thumbnails and where those points lie on our map. So my plan with this algorithm is to make it self-learning so that communities which do not have access to such quality data can help from and can benefit positively from this algorithm and from this data. My app is an effort to detect the best possible water retention site in an environment so that we can manage our water resources better.